Hello and welcome to Samandra Codes, where we learn Python programming in a fun and easy way. This is day 10 of our series, and today we are going to learn all about Python functions and Python parameters. So what are functions and why we use them? A function is a block of code that performs a specific task and can be reused multiple times in a program. For example, the print function is a built-in function in Python that prints a message to the screen. Functions helps to make the code more modular, readable, and maintainable by breaking down a complex problem into a smaller and simpler subtasks. Function also helps to avoid repetition of code by allowing us to write the code once and use it many times with different inputs and outputs. Functions also help to improve the debugging and testing process by isolating and fixing them in one place rather than in multiple places. To define a function in Python, we use def keyword followed by the function name, parenthesis, and colon. The function name should be descriptive and follow the naming convention of Python, such as using lowercase letters and underscores for multiple words. The parenthesis can contain 0 or more parameters, which are variables that received values when functions are called. The function body is intended under the def statement and contains the statements that perform the task of the function. The function body may also contain a return statement which sends the value back to the caller function. For example, let's define a simple function that takes name as a parameter and print the greeting message. Def say name, so it's the name of the function that takes the parameter as the name, colon, enter, automatically indented. So over here, we'll print a greeting message with the name. So we'll use fstring, hello, and in curly braces, the parameter name. We have defined the function sayName, and now we have to call the function in Python. So for calling a function in a Python, we use the function name followed by parenthesis. The parenthesis can contain 0 or more arguments, which are values that are passed to the function when it is called. The argument must match the number and order of the parameters defined in the function, unless we use keywords arguments or default values. The function call is evaluated to the value returned by the function or none if function does not have a return state. For example, let's call say hello function with different names and see the output. So we'll say name Sumant, and when we run it, it will print hello Sumant. One more time, say name, let's say Alex. So it will print hello Alex. Parameters are variables that are defined in the function header and receive value when the function is called. Arguments are value that are passed to the function when it is called and are assigned to the corresponding parameter. There are different types of parameters and arguments in Python, such as positional, keyword, default, arbitrary, and unpacking. Positional parameters and arguments are the most common and simple way of passing values to a function, where the arguments are matched to the parameters by their position in the function call. To use the positional parameter, let's define a function add, which will take two parameters x and y as positional parameters, and over here we'll use return x plus y. So here we have defined function add that takes two parameters x and y and return the sum of the value of the parameter. So let's just run the function add with positional parameter 5 and 3. So when we run it, this will match 5 to x and y to 3 and return the result. Print result, and when we run it, it will output the 8. This is how we use positional parameters. Keyword parameters and arguments are another way of passing values to a function where the arguments are matched to the parameters by their name in the function call, and the order does not matter over here. In positional argument, order matters. So let's again define a function greet with a parameter name and message as a keyword parameter. Now again print, we'll use fstring message, comma, name, we add exclamation. So now if we call greet with the name Alan and run it, it will print hello Alan. So over here, keyword argument name has been assigned to Alice. Now we can again write greet. We can change the position of the keyword argument message to the first argument and the name as second argument. So now if we run it, we'll see that over here, keywords argument are in different order than the way they have been defined in the function definition. So default parameters are parameters that have a default value assigned to them in the function header and can be omitted in the function call, in which case the default value is used. So for example, over here, message is a default parameter, and this can be omitted in a function call, in which case the default value is used. If it's not omitted and assigned a different value, then it will pass the newly assigned value to the function. So we have seen this default parameter in greet Alan. We'll again see greet Smith and we run it. So again, the default parameter hello has been used and we have not passed its value in the function call. So next, arbitrary parameters are parameters that can accept any number of arguments in the function call and are prefixed with an asterisk in the function header. They are usually used for variable length arguments and are stored as a tuple in the function body. So let's define a function with arbitrary parameters. Def calculate average, which can take arbitrary number of integers. So we define total is equal to sum with arbitrary number of integers passed as a tuple to number and then average assigned length of the tuple. Now we'll return the average. Now we call this function calculate average with two parameters and print out. Now again, if I add another parameter and call the calculate average function inside print, then we can see it's taking the three parameters and giving us a correct result. Similarly, I can pass n number of parameters, and if we run it, it will give the correct average. Similarly, double asterisk operator can be used to define a function that accepts a variable number of keywords argument. The arguments are then packed into a dictionary that is assigned to a parameter name. For example, let's define a function, my function, with double asterisk and call it as quarks, just representing short for keywords argument, print quark. Now, if I call my function with keywords argument a equal to 1, b equal to 2, c equal to 3 and run it, this will print a dictionary with key value pair on the output console. And if I print the type associated with quarks, it's a dictionary. So basically, the double asterisk operator can also be used to unpack a dictionary of keyword argument into individual keywords argument. For example, if I change my function having 3 keywords argument, and then if I print them and then define a dictionary with key value pair A1, B2 and C3, and then call my function with star tick as a parameter and run it, so this will print 1, 2, 3 to console. The asterisk and double asterisk operators can be combined to define a function that accepts both positional and keyword argument. For example, if I define my function parameters as a star args for positional argument, arbitrary position argument, and star quark for arbitrary keywords argument, then if I print arg and quark, and in my function I'll first pass positional argument 1, 2, 3 and then keyword argument 4, 5 and 6, and when we run it, it will print the tuple 1, 2, 3 as discussed earlier for arbitrary positional argument and dictionary with key value pair A4, B5 and C6 to the console. So this concludes that the asterisk and double asterisk operators are powerful tools that can be used to handle variable length argument list and dictionaries of keyword arguments in Python. They can make your code more flexible and reusable. The return statement is used to send a value back from a function to the caller of the function. The return statement can be followed by an expression that evaluates to the value to be returned or nothing, in which case the function returns none. The return statement can be used to end the execution of the function, and any statements after the return statements are not executed. The return statement can also be used to run multiple values from a function by using a comma-separated list of expression or a tuple or dictionary of values. The caller function can then unpack the return value into separate variables or store them as a single object. So let's see some example of using return statement in Python. So we'll first define a function that takes two numbers as parameter and return their product. Let's call it multiply. Now let's call the multiply function with two parameters and store the return value in a variable called result. Now let's print the result. So this is the simple way of using a return statement. As we have shown earlier also, we can also call a function inside a function, and its return value will be taken as the parameter to another function. So let's see once more. Def greet return, we'll use fstring hello name. So over here we have defined a function that takes a name as a parameter and returns a greeting message. Now we can call the greet method with a name and it will return a string. And then we can use that string as a parameter to another function, which can be a Python default print function. And we run it, and then it will print hello Sumantra. Okay, so now as a final example, we'll define a function which add and subtract both the value of parameter a and b. So as mentioned earlier, we can return multiple values as a tuple also. So over here, a plus b and a minus b. And we can call this function by using two variables which will have the unpacked value of function subtract 3 and 4. So if I print sum difference and run it, we can see that the return tuple is unpacked into two variables when the function is called, and their values are printed on the console when we print those variables. Next is how to use docstring to document a function, which is very important. Docstrings are special strings that are used to document a function and provide information about its purpose, parameters, return value, and usage. Docstrings are written as the first statement in the function body and closed by triple quotes, which can either be triple single quotes or triple double quotes. Docstrings can be accessed by using the doc attributes of the function or by using help function on the function name. Docstring can follow different formats and convention such as PEP 257. There's a Google convention, NumPy convention, etc. But most important thing is to be consistent and clear. So let's take an example of a function with a docstring that follows the PEP 257 format. Let's define a function again, average, with numbers. So over here, we'll start the docstring by writing triple double quotes, and inside this double quote, we can write our docstring help. Calculate the arithmetic mean of a list of numbers. So our arguments will be number, which is of list type. Should also write a list of numbers. Try to be clear, concise, and descriptive as much as possible. And it will return float value, which will be the average of the numbers. So let's write this function. Let's say if list is empty, then we'll return 0 as an average, or else we'll return sum on the numbers divided by length of the number. Now let's call the function average with a list of number 3, 4, 5 and passed its return value as a parameter to the print function. and run it, should not be lem, should be LE and len, and run it, we'll get the average of the number. So over here, we have defined the docstring in PEP format. And if we want to access this docstrings, comment it first, then we can access the docstring of function by either calling function average dot doc method. And if we print it, it will output the docstring that we have written in the function, which will be very useful for a programmer or a developer who is trying to understand the functionality of function and how to use it. We can call this with the inbuilt help function, passing the name of the function as a parameter, and if we run it, it will again print the same docstring. To conclude this video, let's do a hands-on exercise that demonstrates the use of functions and parameters in a real use case. Suppose we want to write a program that calculates the area of different shapes, such as rectangles and triangles. We can use functions to define the formulas for each shape and use parameters to pass the dimensions of the shape to the function. We can also use return statement to send the area value back to the main program and print them in a formatted way. Let's see how we can do this in Python. So let's begin by first defining a function that takes the length and width of a rectangle as a parameter and returns the area. So define rectangle area, which is going to take length and width of the rectangle as parameter, and calculate the area of the rectangle by multiplying length into width and then returning the value of the area. Next, we define a function that takes the base and height of the triangle as parameter and returns the area by using the formula half into base into height. Def triangle underscore area will pass base and height as a parameter, and then we'll calculate area as 0.5 half into base into height, and then return the area. So for the rectangle, we'll use a length of 10 and a width of 6. We'll create again a variable rect area, which we'll call rectangle area function with parameter 10 and 6, and it will print in f string the area of rectangle is, in curly braces, rect area with format point to f. That's it. Similarly, for the triangle area, we'll use base of 8 and a height of 6. We'll define a variable triangle area. I have not spelled triangle correctly. It should be triangle area. Now, yes, triangle area A6, and we'll again print in f string the area of triangle is, again in curly braces, triangle area with format specifier to f. That's it. We are done. Now if we run this program, it will output the area of rectangle as 60 and the triangle area as 24 by calling the function rectangle area and triangle area and printing the output. This concludes our session for today. In the next episode, we'll learn about Python variables, scope, and global variables. If you have any questions or feedback, please let me know in the comment below. Thanks for tuning into Sumanth Codes. If you found this helpful, give it a thumbs up and subscribe for more coding tutorials, tips, and insights. Hit the notification bell too, and let's continue this coding journey together. Stay tuned.